Welcome everyone to RC Programming. This is my second video in the Computer Network and Security series. And naturally, it's about communication and network protocols. In this video, we are going to be discussing about the following topics. So first, let's talk about the communication protocols. A communication protocol is simply a set of rules that govern how data is transmitted between devices in a network. Just like people need a common language to understand each other, computers and networks use protocols to communicate effectively. Protocols define how data is formatted, when it can be sent, how errors are detected or corrected, and how connections are established or closed. This standardization ensures that devices from different manufacturers, like your phone, a laptop, or a web server, can all access data reliably. The Internet relies on layers of these protocols such as HTTP, TCP, IP, and DNS, which we'll explore next. Hypertext Transfer Protocol, or HTTP for short, is the foundation of web communication, the reason your browser can load web pages. It works at the application layer using a simple request-response model. Your browser, or which can be called the client, sends an HTTP request and the web server responds with a web page, image, or data. The secure version, HTTPS, uses encryption through SSL or TLS to protect the data being exchanged, especially important for online bankings or logins. For example, when you type HTTPS google.com, your browser sends an HTTPS request to Google server, which responds with the homepage data. TCP, or Transmission Control Protocol, ensures that data is delivered accurately and in the correct order. It's a connection-oriented protocol, which means it first establishes a reliable connection before transferring data. TCP uses acknowledgements to confirm receipt of packets and retransmits any that are lost or damaged. This makes it ideal for applications where reliability is critical, like downloading files, video conferencing, or sending emails. For example, when you send an email, TCP ensures that every byte of your message reaches the recipient's mail server correctly. Next, the Internet Protocol, or IP for short, is responsible for identifying and routing data between devices across the Internet. Every device connected to the Internet has an IP address, which acts like a digital mailing address. When data is sent, IP divides it into packets and ensures each packet is routed across different networks to reach its destination. IP doesn't guarantee reliable delivery on its own. That's where TCP comes in, working together as TCP/IP. For instance, when you access a website hosted overseas, IP ensures your request is routed through multiple intermediate routers and networks to reach the correct server. Here's the TCP/IP suite, which is the backbone of the Internet, defining how devices communicate reliably. It uses a layered approach. The application layer provides services like web browsing, HTTP, and file transfers, FTP. The transport layer ensures data is delivered correctly with TCP or quickly with UDP. The Internet layer handles addressing and routing using IP. Those are of different types, IPv4 and v6. Let me know if you want videos on those two. And the link layer connects to physical networks like Ethernet or Wi-Fi. This suite is scalable, interoperable, and ensures reliable delivery of data. For example, when you visit a website, DNS resolves the domain, TCP segments the data, IP routes it across the network, and TCP reassembles it so your browser can display the page. And although we always say TCP/IP in the same breath, and often they are viewed as one entity, they play very different roles while still working hand in hand. Let's start with what they share. Both are essential to data transmission over the Internet, and both used packet-based methods to move information between devices. And the difference lies in their focus. TCP ensures reliability, making sure every piece of data arrives in order, while IP is more about logistics, getting the package to the right place. You can think of IP like the postal service that delivers envelopes, and TCP as the system ensuring that all the letters arrive and are arranged correctly. For example, during a file download, IP delivers each packet and TCP ensures none are lost or out of sequence. You can look at more differences on the screen, and we'll move on to DNS, or domain name system. It makes the internet user friendly by translating domain names into IP addresses. Imagine if you had to remember every website by its IP address, it would be nearly impossible. DNS solves this by acting like the internet's phone book. When you type www.youtube.com, your device contacts a DNS server, which returns the corresponding IP address so your browser can connect to the right server. This happens behind the scenes in milliseconds, allowing users to browse with simple, readable names instead of numbers. And this is where we are going to be stopping for this video. Next is about network performance and security. It's already been uploaded, so see you in the next one. And as always, please like, comment, and subscribe.